Hi everyone, welcome back. Today we're going over the notes on page 4 of our chapter 4 packet. We already did page 3, so today we're starting up here with number 17. And the answer for this question here is negative. A negative slope means the object is moving back towards where it started. And this is, of course, referring to a graph of distance or position versus time. So we're used to seeing position or distance from where you started changing in a positive slope, but if you are moving back towards the origin, it would be a negative slope. So that's 17. Number 18, the answer for that one is actually going to be changing. Changing velocity is shown with a curved line on a position versus time graph. So going back to that graph of distance or position versus time, if this is representing constant speed because it has a flat line. If it were a curved line, then distance is changing at a rate that is not constant. In other words, your speed is changing. And the word for that is acceleration. So even though the word changing goes here for number 18, off to the side here you could write the word acceleration to describe changing speed over time. And speed is going to actually be our answer for number 19. That's the first answer here. Speed versus time graph is also useful for showing the motion of an object that is speeding up or slowing down. And then for number 20, you could put either flat, would probably fit best, or straight. A horizontal line is going to represent on a speed versus time graph. That's going to show an object moving at constant speed. There is zero acceleration if there is zero slope. And then the next sentence here for number 20 says that this should say curved positive slope means it's speeding up, and then a curved negative slope. So that would kind of look like that. Well, that would look like that. Means that it's slowing down. And that's, of course, number 20 is referring to a graph of speed versus time, which is different than what we've used before in terms of position versus time. And so speed versus time, this is again describing acceleration, which is what lesson 3 is going to be all about. So on this first blank, you're going to write the word acceleration here for number 21. That's the rate at which your speed or velocity changes. It is any change in velocity, and velocity includes speeding up, so this should be speeding up, slowing down, or changing direction. Because remember, the difference between velocity and speed is simply direction. So even if you are traveling at constant speed, if you change your direction, technically you're changing your acceleration. So that one was acceleration, speeding, and changing. For number 22, acceleration describes how quickly speed changes. I know this is a little repetitive, but it's important for us to make these ideas clear in our heads. So acceleration is the change in velocity is going to go here, divided by the change in time. So the next one, number 23, talks about the units, which is really important. The units for acceleration are the units of speed per unit of time. Now, we learned in the last chapter that the units for speed are going to look like meters per second, or in our lab we did centimeters per second. We also did a lot of problems with things like kilometers per hour or miles per hour, as people often use in this part of the world. But if acceleration is change in speed over time, then the units are going to be over time once again. So it could be kilometers per hour per second or kilometers per hour per hour. So it's the rate at which speed is changing. So I know this looks funny. As you may have learned in math class, another way to write that would be centimeters per second squared. That's the same. And so that's what we're going to try to clarify right in here for number 23. Units for acceleration, we said, are going to be a unit of speed per unit of time. And three examples that your book gives, one of them is kilometers per hour per second, would be how you would write that. And that's the same one that we put up here. And another example might be miles per hour per second. And in science class, we don't often use miles because that's not metric. But again, it is often used in this part of the world. And then the third example that your book uses is meters per second squared. That's the one that we're most commonly going to use in this class. So the standard metric unit is that meters per second per second. And again, as you may have learned in math class, that is the same as meters per second squared, which is what's going to go in here. Meters per second, or it's pronounced meters per second. The word squared is going to go here. Next up for number 24, there's a math problem here. This one is also illustrated in your book if you want to take a look at it there. An acceleration of 20 kilometers per hour per second means that the speed increases by 20 kilometers per hour each second. So after 1 second, the speed is 20 kilometers per hour after that first second. But then after 2 seconds, now you're going 40 kilometers per hour, and so on. So it's increasing by that amount each second. And that's where that exponent comes from. Number 25, here's a sample problem in which we need to apply the slope formula, actually, is the same as the formula for acceleration. So acceleration is change in speed over time. So you could think about that as like your final speed minus your initial speed over the change in time. And it would be your final time minus your initial time. But we usually start initial time as 0, all the problems that we are ever going to do. So in this problem, if we're doing our final minus our initial speed, it's going to be 4 meters per second minus 1 meter per second. And we're going to divide that quantity over the change in time, which in this problem was 3 seconds. I know I'm going into the question 26 below. Sorry about that. I have to write big. And if I plug that into a calculator, 4 minus 1, remember I'm doing the quantity of 4 minus 1, so that's 3, over my change in time, which is also 3. So my rate of acceleration is 1 meter per second squared. Remember, it's meters per second per second. That's where I got my meters per second squared. You may want to review that one. Those are tough. If you want any practice with acceleration problems, please let me know. I'll be happy to go over those with you.